Hello students, today we shall learn to convert rational numbers in decimal form to its fractional form p upon q form, okay? And I've chosen 3 questions, and by the end of this video we shall be able to convert any rational number in decimal form to its fractional form p upon q form, where p and q are integers and the value of q should not be equal to 0, okay? So let's do this question. Let us express each of the following numbers in the form of p and q, where p and q are integers and q not equal to 0. So we have question number 1, 1.3, and there is a bar over 3. So this is a rational number in decimal form. We are asked to convert this decimal rational number to its fractional form p upon q form, okay? So first let us understand what is bar. So we have 1.3 and there is a bar over 3, which means 3 is repeated again and again, okay, up to infinity. 3 is repeated many times up to infinity, okay? 1.3 bar means 3, 3, 3, 3, 3 and so on. So what we do is, first let us suppose this number to be x. X equal to 1.333 and so on. This is equation 1, okay? Bar over 3 means 3 is repeated many times. Now what we do is, let us multiply both sides of this equation by 10, okay? So 10 into x is 10x. Again 10 into this number, 10 into 1.333 means when we multiply, suppose 1.3 into 10, what happens is 0 3s are 0, 0 1s are 0, 1 3s are 3, 1 1s are 1. So this 0 we write here, this 3 we write here, this 1 we write here, and there is a decimal point before one digit number, so we put a decimal point here, which means decimal is shifted backward, okay? When we multiply with 10, decimal is shifted one digit backward. So what we do is 13.333 and so on. This 3 3 are many times, okay? 3 3 3 and so on. This is equation 2. This is equation 1. When we multiply both sides of this equation by 10, 10 into x is 10x, and 10 into this number is, see, the decimal was here, and when we multiplied this number with 10, the decimal is shifted one number backward, okay? So 13.3333, there are many 3's up to infinity, isn't it? So this is equation 2. Now what we do is, we subtract equation 1 from equation 2, okay? So let us write equation 2 again. 10x equal to 13.333 and so on. This is equation 2, isn't it? And equation 1 is x equal to 1.333 and so on, isn't it? X equal to 1.333 and so on. This is equation 1. So we subtracting equation 1 from equation 2, this becomes minus, this becomes minus. 10x minus x is 9x, isn't it? 10x minus x is 9x, equal to, so here 0.3333 and so on, 0.3333 and so on. After decimal point, only 333 are there in both the equations. So after decimal point, we have 0. 0.33333 minus 0.3333 will give us 0, isn't it? So before the decimal is 13 minus 1, that gives us 12. So 12.0 is 12, so we don't write this, okay? 12.0 means 12, isn't it? So or x equal to this 12 we write here, and this 9 we cross multiply to the denominator on the other side, okay? So 3 3s are 9, 3 4s are 12, or x equal to 4 upon 3. This means we had supposed this number to be x, 1.3 to be x, isn't it? X is 1.333 and so on. So x means this, which means 1.333. This is a decimal form and this is a fractional form, where p is 4, and q is 3, okay? Where p is 4 and q is 3, p upon q form, isn't it? So this is the answer for question number 1. We have converted decimal number, decimal rational number to its fractional form p upon q form. Okay, now let us do question number 2. Question number 2, 0.54, and there is a bar over 4, which means 4 is repeated many times, okay, not 5, because there is no bar over 5. So let us suppose this number to be x. Let x equal to 0.5. So there is bar over 4, means 4 is repeated many times, 4, 4, 4, and so on. Uncountable number of 4s, okay, infinite number of 4s. So this is equation 1, 0.54444 and so on. Now let us multiply equation 1 with 10. Okay, let us multiply equation 1 with 10. So 10 into x will give us 10x equal to 10 into this number. 10 into this number means decimal point will move one digit backward. Okay, this decimal will move here one digit backward, because we are multiplying this number with 10, isn't it? So 5.444 and so on. This is equation 2. Now our main objective is to make the numbers after decimal point same. In equation 2 we have 0.44444, but in equation 1 we have 0.54444 and so on. So the numbers after decimal points are not same. So what we do is we again multiply equation 1 with 100. Okay, when we multiply equation 1 with 100, so 100 into x will give us 100x. I am multiplying equation 1 with 100, this equation with 100. 100 into x is 100x equal to 100 into this number, means this decimal will move 2 digits backward. Okay, this decimal will come here, this decimal will come here. When we multiply this number with 100, this decimal will come here, which means 54.444 and so on, and this is equation 3. Okay, there are many 4s. I am writing only 3 4s, but there are many 4s. Okay, now let us check equation 2 and equation 3. In equation 2 the numbers after decimal point is 0.44444 and so on, and in equation 3 the number after decimal point is 0.444444 and so on, isn't it? Which means the numbers after decimal point in both the equations are same. Now what we do is we subtract equation 2 from equation 3. Okay, let us write equation 3 again. 100x equal to 54.444 and so on. This is equation 3. And equation 2 is 10x equal to this number 5.4444 and so on. This is equation 2, isn't it? So let us subtract equation 2 from equation 3. Okay, subtracting 100x minus 10x will give us 90x. 100x minus 10x will give us 90x. Let us see the number after decimal. Okay, 0.444 and here also 0.444 and so on, same number. Okay, which means when we subtract a number from the same number we get 0, isn't it? 0.44444 minus 0.4444 will give us 0. So this decimal comes here. 54 minus 5 will give us 49. 54 minus 5 is 49, isn't it? So x equal to 49.0 means 49. Now this 90 is cross multiplied to the denominator on the other side, so 90 will come here. So this is not cancelable, so we keep as it is. Okay, so we were asked to convert 0.54 bar, this decimal rational number, in the form p upon q, and we have converted this number in the form of p upon q, that is 49 upon 90, which is p upon q. P is 49 and q is 90. Okay, required fraction is 49 upon 90. Okay, this is the answer. Now let us do question number 3. Question number 3, 0.001, and there's a bar over 0 also and over 1 also, which means all these three numbers 0, 0, 1 is repeated many times. Okay, infinite number of times. So let us suppose this number to be x, which means let x equal to 0.001, 001, 001, and so on. This continues. Okay, this is equation 1. 001 is repeated many times. 001, 001, 001, 001, and so on. This number is repeated many times. Now what we do is we try to make the numbers after decimal points same, isn't it? So what we do is we multiply equation 1 with 1000, okay, because there is decimal is before 3-digit, so we multiply with 1000. When we multiply with 1000, this decimal moves 3-digit backwards. So 1000 into x will give us 1000x. 1000 into x is 1000x. Now 1000 into this number, 1000 into this number is, when we multiply this number by 1000, this decimal move 1-digit, 2-digit, and 3-digit here. This decimal will move here, 1, 2, 3, after 3 digits, isn't it? So this one we write here, this one we write here. 001 means 1, isn't it? This one we write here, and then 001, this continues. Okay, 001, 001, 001, and so on. This is equation 2. Now we subtract equation 1 from equation 2. Okay, why? Because we have after decimal point same numbers, isn't it? 0.001, 0.001, 0.001, and so on. Here also 0.001, 0.001, 0.001, so on. Means the numbers after decimal points are same in both the equations. So we subtract equation 1 from equation 2. So let us write equation 2 again. 1000x equal to 1.001, 001, 001, and so on. This is equation 2. And equation 1 is x equal to 0.001, 001, 001, 001, and so on, as many times as you can. Okay, you can write as many times as you can. This is equation 1. So 1000x minus x will give us 999x. 1000x minus x will give us 999x. Now when we subtract, let us see the numbers after decimal point only. Same numbers after decimal point, isn't it? When we subtract same number, we get 0. So we write 0 here after decimal, and before decimal we have 1. Okay, so x equal to 1.0 means 1, and this 999 will go to the denominator by cross multiplication. So we were asked to convert this number in P upon Q form, isn't it? This number to P upon Q form. So the P upon Q form of this decimal rational number is 1 upon 999. Okay, P is 1 and Q is 999. So required fraction is 1 upon 999. Okay, I hope you got this. Okay, thank you so much. Stay connected and practice well. Okay, I'll upload similar type of questions in the future too.